This is the Castle Peak Power Station, one of the largest coal-fuelled power stations in the world. It covers an area of 62 hectares, about the size of 4 Victoria Parks. There are 8 power-generating units in the plant. The core of the control centre is this control panel. Here, every line represents a series of units carrying out related tasks. The crisscrossing of so many lines and the blinking of the indicator lights shows that the control work is heavy and complicated. There is also a control centre in the human body. It is much smaller in size, but is thousands of times more complicated and hundreds of thousands of times more efficient. This baby is only 6 months old. He has not yet started school. Every movement he makes is out of instinct. Tickle the sole of his foot with a feather. He withdraws his foot. Put a toy in his hand. He holds the toy tightly. Put the toy in front of him. He looks at the toy with his eyes and reaches out for it. Shake the toy to make a noise. The baby immediately turns and looks at the toy. We can see that a baby perceives and reacts to changes in the environment instinctively. When the sole of his foot is stimulated, he reacts with his foot. There is also a special expression on his face. This shows that when the body is stimulated, the message is passed to the head. Compare the time needed to respond to stimulation in front of his eyes with that of responding to stimulation on his foot. The response to the former is much quicker. This shows that the control centre of our senses is located in the head, that is, in the brain. The structure of the human body is similar to that of a guinea pig. In the head of the guinea pig, the cranium is beneath the skin. On the guinea pig's back, there is a spine beneath the skin. It is made up of a number of vertebrae lining up one after the other. These thread-like substances are nerves. They connect the spinal cord to various organs in the body. Cut open the skull and there is a milky white substance. This is the brain. Cut open the back of the spine and we can see a milky white spinal cord inside. The spinal cord is connected to the brain. The nerves of the organs in the head and the neck are also connected to the brain. This is the same for the human body. The brain and the spinal cord form an axis. The nerves are like wires extending from the axis to make up a complicated network covering all the organs in the body. The brain, the spinal cord and the nerves form the nervous system in the human body. The human brain is made up of 3 major parts: the cerebrum, the cerebellum and the brainstem. The left and the right halves of the brain are symmetrical. We may cut the brain vertically into 2 halves. From this cross-section, we can see the relationship among these 3 main parts. The brainstem is located at the bottom of the brain. It looks like a baseball bat, thick at one end and thin at the other. The part of the brainstem connecting to the spinal cord is known as medulla. The nerves of the eyes, ears, tongue, nose, and other parts in the head and the neck are connected to the brainstem. The nerves of the organs and tissues of the body below the neck are connected to the medulla through the spinal cord. The function of the brainstem is to control and adjust the reflex action of the eyes, ears, and other internal organs, and various complicated physical processes. The function of the cerebellum is to maintain the balance of the body and the tension of the muscles of the body, and to coordinate the voluntary actions of the muscles in the limbs. The cerebrum is shaped like 3/4 of a football, with grooves on the surface. In the middle is a deep furrow, dividing the ball into 2 halves. There is also a central horizontal groove on the top of each of the 2 halves. The cerebrum is the master control center of the nervous system. Scientists use the technology of magnetic resonance to monitor the activities of the cerebrum and observe that when people look at things, the back of the cerebrum is very active. When people listen to sounds, the middle part of the left and right sides of the cerebrum is very active. When the limbs and the surface of the body are stimulated by a pin, the top of the cerebrum at the back of the lateral groove is very active. When people move their limbs, the top of the cerebrum in front of the lateral groove is very active. When people think, the front of the cerebrum is very active. The sensory cells in the sense organs and various parts of the body, when stimulated, send nervous impulses to the brain through the network of nerves or the spinal cord. In the brain there are a number of control centers handling these messages, giving rise to senses and giving out instructions for activities. These instructions are transmitted to the nerves directly or through the spinal cord, reaching the relevant organs and tissues to start them working. Many of us enjoy meals served on hot plates in restaurants. Sometimes a restaurant will put the food on a hot plate and serve black pepper sauce on it. The tickling sound and the appetizing smell of the sauce, augmented by the high temperature of the hot plate, makes the food particularly delicious. But if you have a bad cold, you will find the same sizzling meal less tasty. Why? When you enjoy a meal served on a hot plate, the black pepper sauce and the food on the hot plate react to the high temperature and release odour molecules. These enter the nasal cavity and stimulate the olfactory nerve endings. When you eat, the taste buds on the tongue are stimulated by the food molecules. The 2 senses act on each other and result in the reinforcement of these senses, so you will find the food particularly delicious. If you have a bad cold, the olfactory nerve endings are less sensitive to molecules released by the food. So, when you have your meal, your brain can only receive messages from the taste buds on your tongue. You only retain the sense of taste, unaided by the sense of smell, so the food seems less enjoyable. There are 2 concentric circles in this picture. Are their lines very smooth? Place the circles on a background of many broken lines. Are their lines still smooth? In fact, the circles have not changed. Why were they different just now? Look and see if these parallel lines are straight lines. Place the lines on a background of many broken lines. Are they still straight lines? In fact, the parallel lines are straight all along. Why were they different just now? Look at these two parallel lines. Which one of them is longer? Is it the one below? Now, measure them with a ruler. They are of the same length. But why do they seem to be of different lengths? Look at the black portion of this picture. Is this a rectangle? Now measure it. It is in fact a square. But why does it look like a rectangle? These are 4 examples of optical illusion. Optical illusions are formed when the sense of sight created by the cerebrum is interfered with by the crisscrossing of lines in the background. Some pictures look different to different people. This picture looks like a young lady to those who are used to looking at things from the top to the bottom. But for those who are used to looking at things from the bottom to the top, this looks like an old witch. For those who are used to looking at the background of a picture first, this looks like a vase. But for those who are used to looking at the centre of a picture first, this looks like 2 people facing each other. These 2 examples show that the subjective views of a person can affect the sense of sight, thus giving rise to illusions. Cover the eyes of the child so that she cannot see the things in front of her. Now, we ask her to put her finger into each glass of water and tell us how they feel.
The water is neither hot nor cold. It's hot. It's cold. It's cold. It's hot.
This experiment shows that human senses are affected by the environment and are not very reliable. So, we have to rely on scientific instruments to help measure absolute values. This makes up for the deficiencies of our senses. Some people may react to external stimulation that does not exist. These senses are known as hallucinations.
Many people have misunderstandings about hallucinations. Some patients will say, no, it's not a hallucination, it's real. People generally think that hallucinations are like what we see in a dream. In medical terms, we have hallucinations when we perceive images, sounds, smells, or even touches when there is no external stimulation. These feelings are no different from what we actually feel when there is actual external stimulation. In other words, what we hear and see in hallucinations is exactly the same as what we hear and see in the real world. The patient usually cannot identify them as hallucinations. There's no fixed pattern in the symptoms of patients suffering from hallucinations. Basically, their behavior is very strange. For example, they will turn suddenly and seem to be talking to a void or to themselves. Also, as they see things that do not exist, they may suddenly look as if they are very frightened, or even start to attack something or defend themselves. These actions look strange to bystanders. Having hallucinations is in fact a morbid condition. Despite the absence of light or images, the nerves at the back of our eyes, for some unknown reason, transmit inaccurate or wrong messages to our cerebrum, giving rise to senses that are inaccurate or do not exist. How does this morbidity arise? There are usually 3 circumstances. First, people take drugs or medicines that interfere with the transmission of messages. Second, the condition may be hereditary. Hereditary problems of the nerves result in inaccurate transmission of messages. Third, a normal person inflicted with a trauma or emotional disturbance may suffer from this morbid condition. There are many types of psychotropic drugs. Some are actually called hallucinogens. As suggested by the name, hallucinogens may cause hallucinations to the drug taker. Other drugs may also cause hallucinations. These include stimulants or even cough syrup, organic solvents and alcohol. If they are used excessively or inappropriately, they may also cause hallucinations. After we've taken psychotropic drugs, the drug will circulate through our body, and the damage will be to the whole body and not confined to a particular spot. But the most worrying and serious consequence is that it may affect our brain, which is fragile and important to us. Once that's damaged, it will not be able to recover. When psychotropic drugs affect our cerebrum, brainstem and cerebellum, the important functions of our brain will be damaged. These include our memory, concentration, analytical power, control of limbs, adjustment of fine movements, control of emotions, including our temper, emotional fluctuations, and the ability to control ourselves. This is a radiographic image of a human brain. On one side is the brain of a normal person. On the other side is the brain of a drug abuser who had stopped taking drugs for 3 weeks. We can see that the brain has not recovered even though 3 weeks have passed after the abuse of drugs. The adverse effect still lingers. The image is relatively dull in color, meaning that the nerves of the brain are less active, so the person is less alert and less effective in his reasoning and memory. Here are the results of medical study. The first picture shows a normal brain cell. Here we have a cell nucleus and some nerve endings. The cell is responsible for transmitting information and messages in the brain. The picture in the middle shows the cell of a person who has abused drugs for a short period. We can see problems appearing. The shadows at the nerve endings indicate that the transmission of messages is affected. The last picture reveals a very serious problem and a medically worrying situation. After a long period of drug abuse, part of the nerve has decayed and the remaining part of the nerve experiences new growth, creating interferences to information transmission. The logical thinking and other functions of the brain are disturbed. Perhaps you've heard people saying this: taking drugs will add fun to the party. They might say that a little drug could not cause any problems, and that you'll not be addicted because it's not heroin. This is wrong information. Psychotropic drugs are very dangerous and will cause permanent damage to our brain cells. So don't ever try illegal drugs.